So I used to do this lecture first because it kind of breaks down what shielded metal arc welding is as far as the phrase. So we're going to break it down here. The reason I switched it to the second lecture was because the second lecture had all the electrode characteristics that you were going to be using in the actual lab, so I wanted to move that to the first lecture. So shielded metal arc welding refers to a method of joining two pieces of metal or adding metal to an existing surface. So that'd be like a surfacing weld. You're just trying to build it up. That's pretty much what you're doing with these blocks. You're just building it up, right? Each word conveys an attribute of the process. So we're just going to break down the actual term, well, phrase, shielded metal arc welding. First word is shielded. Refers to its ability to displace the air surrounding the weld to avoid harmful effects of the gases in the air. Atmosphere is made up of 79% nitrogen, 20% oxygen, some CO2, some other stuff, argon. If it gets into the weld, it tries to escape as it's solidifying and gets all this porosity. That's why you gotta have some kind of shielding. The stick welding is the flux. Meg and TIG has a separate shielding gas, right? That's why they have the tanks on the back that we were just talking about.
So did you put new tanks throughout the lab then? Because like half of them were empty.
No, we just put them in the tank area, and then whenever somebody wants to use them, they put them on. Yeah, remember, they're really heavy. Don't be a hero, and that's how you get a hernia. Metal, generic term for the many, many metals there are, right? Whatever you're welding, that's what it's going to be composed of. So if you're welding low carbon steel, it's going to be low carbon steel. If it's aluminum you're welding, you're going to have an aluminum in the middle. Denotes the core of the electrode. Arc. Refers to plasma discharge that converts electrical energy into heat. So there's an arc plasma in the welding processes, just like everybody thinks when they hear plasma cutters, but yeah, they are, there's a plasma in the arc as well. ionized gas, right? That's why the electricity goes over a gap, right? Welding. Denotes that the metals are joined or fusion. It's mixing together, it's fusing, that's why it's so strong, right? It's not like a glue where it's just sticking together, it's fusing, it's mixing the base metal with the filler metal and fusing it. The electrode must meet 3 pieces of criteria. It must shield the arc and the weld metal let's back this up a bit here for a potential test question, right? So I'm going to go back up here real quick. On the test, I write down, in regards to the phrase shielded metal arc welding, which word refers to its ability to displace the air surrounding the weld to avoid the harmful effects of the gases in the air? And you're right, shielded. It has to be shielded, metal, arc, or welding, one of those 4 words. People put stuff that does, it's not the 4 words all the time. And I have no idea why they do. So it's like, it has to be shielded, metal, arc, or welding, right? So just so you know, with regards to the phrase shielded metal arc welding, which word denotes the core of the electrode? You're right, metal, right? Alright. People put other words than besides the word shielded metal arc welding. It's very bizarre. Lost it. Add metal to the weld. So we're back to the 3 pieces of criteria electrode must meet. First was it's got to shield the arc and the weld metal. The next one is add metal to the weld. We missed you.
My phone is on silent, so my alarm will go up.
It happens.
Not too bad.
Does everybody have their phone, stuff they use for their alarm clock? I used to set remind messages out and they'd be like, you woke me up at 6 o'clock in the morning. I was like, why do you have your phone sit right next to your head? That's what I use for my alarm. I got one of those old alarm clocks, like the digital things where it goes off, you go into panic mode and start fighting yourself in the bed because you're so, you don't know what's going on. It has one of those, like so loud that the windows vibrate. Yeah, it's,
I jumped up at 3:15 this morning, like, oh, I'm gonna be late. I'm just like, my alarm's went off. Oh my God, no, it didn't. I just heard it in my head.
panic attack. It's got to shield the arc, the weld metal. It's got to add metal to the weld, and it's got to sustain the arc. They put arc stabilizers in the actual flux. So it's going to add metal, it's going to shield it, it's going to sustain the arc. If you take a bare electrode and try and weld with it, it goes all spastic and all over the place. You'll see that when you're 7018, when you break the end of the flux off, when you first start, it goes all spastic, that's what it is. It doesn't have the arc stabilizers in it from the flux. The covering, lost it, contains ingredients. That when sufficiently heated, decompose into gases, displace the air at the weld site. Thus providing a shield for the arc and the weld metal. You're in a common term, right? Shield. So it's got the name shielded metal arc welding. Ionize to support the arc plasma. We're not going to go into ionization, right? But when you get into chemistry, right? So we're going to go over all that stuff, and welders all say, "Why do I got to take chemistry?" There's an amazing amount of chemistry involved in welding. You can get into it really deep if you want to. I took a class called Arc Physics at Ohio State. It was the hardest class I ever took. Going over the physics behind an arc. It's pretty rough. I tried to cheat on it. I got a guy with a PhD in physics to look at it, and he goes, "I can't figure that out." Walked away. I was like, "Oh, that's what I wanted to hear. Great." So there's a lot of chemistry involved in welding. People just don't know it, usually. All that bonding stuff, right? Ionization. Yeah, anyways. It's got a flux to molten weld pool. Anytime they're talking about fluxing, it means drawing out the junk. It's fluxing it. It's going to flux the weld pool, and on cooling, form a protective slag cover on the weld bead. So that slag cover, we're talking about the slag lifting up as you're getting done. That's actually that's not bad, but it'd be better if it stayed on because it's, shielding it still as it's cooling. It's kind of like a post-purge on a MIG or TIG where the gas keeps coming out after you're done. That's the same thing with that slag. It's when it's still cherry red or orange, it can still draw in atmospheric contamination. So when that bead lifts up, it's not exactly a good thing. It's not necessarily bad enough to do anything, make the weld, have a bunch of holes in it or anything, but it's there for a reason. It's there to cool it and protect it from the atmosphere. one more section here, principles of operation. So this is what's happening with the whole process. And a step-by-step list, I guess. The process uses electric circuit. That supports a welding arc to convert electric line or fuel into heat. I feel like people don't think of electricity as a fuel, but it is. We got underlines all over the place. We got here uses electric. Or uses an electric circuit to convert, let's see, electric line. Lines? No. Ignore. Google's never wrong, right? So it's turning electricity into heat. The heat from the welding arc is intense and extremely concentrated. Lost it, and immediately melts a portion of the workpiece as well as the end of the electrode. So it's going to melt both the workpiece and the electrode and then fuse, right? The welder, and by the welder we mean the human being running the welder, not the actual machine, maintains the arc length by holding a consistent space between the electrode and the weld pool that forms on the workpiece. Whew. Arc length is important, right? Bold it. Oh, it already was bolded. Underline it. Italics. You want to maintain a consistent arc length that keeps your electricity going nice and smooth. Doesn't have fluctuations going all over the place. When you raise and lower that arc length, the volts are going all over the place, right? It's a constant current machine. It's going to try to maintain the current, so the volts are going to fluctuate. It's all in a mathematical formula because every welder likes math. It's fact. Last bullet. One thing I forgot to mention last class was how to extinguish the arc, right? Which I know you all figured it out, but you just pull away, right? That's how you get rid of the arc. It's not like make or take where you stop pulling the trigger or stop pushing a foot pedal down. You just get away from it, and that's what makes the arc stop. You're just breaking that basically an electrical circuit. You all figured it out, right? It's an obvious thing if you've welded before, but if you've never welded before, I've had people go, how do you get to stop? Let's say you just pull it away, man. But like, there's people that have never welded before and they don't know. And they're welding away and then they're yelling in their booth and then they pull it away really slowly and it's like, whirr, you can hear it when somebody does that. So, it's the lightsaber effect, right? I've never seen any Star Wars movie, just so you know, and I take great pride in that. One of my buddies is a Star Wars freak. His name is dog Yoda. He's got a Boston Terrier named Yoda. He's got Yoda figurines. It's the only reason I know anything about Star Wars.
You don't gotta be like nuts about it, but like at least watch the movies, they're pretty good.
Are you kidding me?
I haven't watched the movies either.
Good man right there. As the arc is removed, the liquid, his new dog is named R2D2.
That's just really cheap.
That's a robot or something you said?
It's a droid.
You got the posters and everything. As the arc is-
Technically, it's a droid.
As the arc is removed, the liquid fuses and the melt solidifies into continuous metal.
You can't tell me you never played Star Wars Battlefield.
Nope. True
Or
story.
Battlefront, sorry.
You're gonna want to keep that to yourself.
No, it's a pretty good game, actually.
I played
See,
the game.
see, he's played the game. He hasn't seen the movie, he's played the game.
I played it on the NES.
Oh, yeah. I played it on
That.
Xbox. Like the original Xbox.
Yeah.
Battlefront 2 was my favorite. Hard to get, see.
Wait, this is, It doesn't get more exact than that. I didn't know. Oh yeah, you did. I got it on video. You knew. I would be able to back that. I like that. I can back it up. I didn't know. Oh, wait a minute now. Rewind. You knew. Quiz 1, Thursday, 9/3/2020. If you missed a class, I think everybody's here except for you missed the last class, I'll give you the notes. If you want me to copy the notes, I can copy them for you too. Just came in late. I think everybody else is all set. All right? In the lab, we're going to continue on our flat. I'm going to draw some stuff here on the board. I forgot to tell you last class. But I have to go get my board kit.
Because you don't have the markers because of Corona.
Yes. All right.